Hi everyone. In this video we are going to discuss some problems related to the force voltage and force current analogy. So this is the problem. The problem is write the differential equations governing the mechanical system shown in figure 1. Draw the force voltage and force current electrical analog circuits and verify by writing mesh and node equations. So that's the problem, and this is the mechanical translational system. Okay, figure of a mechanical translation system. So we have to write the differential equations governing the system, and also we have to draw the force voltage and force current analogous circuit. Okay, so by observing this figure, it is clear that there are two nodes M1 and M2. So for writing the differential equations, we have to draw the free body diagram of these two nodes M1 and M2. And first step is to draw the free body diagram of M1. Okay, so from this figure it's clear that we are applying a force F of t to this M1, and the opposing forces will be the opposing force due to the mass M1, and the opposing force due to the frictional element B1, and opposing force due to this B12, and opposing force due to this spring K1. Okay, so this is the free body diagram. F of t is applied force. Okay, and here in this figure the direction, okay, that is the F11, the opposing force due to the mass M1. Okay, F11, then the opposing force due to the B1, that is frictional element B1, and B12, and Fk1 is shown here. Okay, so these are the opposing forces. Okay, these are the opposing forces. So here the direction is same as of F of t, but you have to draw the direction opposite to that F of t. Okay, so a simple mistake in the figure. So this is just opposite to that of the F of t here. Okay, so we have to write the equations for all the opposing forces. We know that F11 will be equal to m1 into d square x1 by dt square, because x1 is the displacement for the m1. Okay, we are taking this displacement x1 here. Okay, and Fb1 will be equal to b1 into dx1 by dt. b1 is only related to the m1 only, and this k1 and b12 is common for these two nodes. Okay, so the equation will be Fb12 will be equal to b12 into d by dt of x1 minus x2. Fk1 is equal to k1 into x1 minus x2. Okay, so for writing the force balance equation, the force balance equation is F11 plus Fb1 plus Fb12 plus Fk1 is equal to F of t. Okay, and m1 we are substituting the values. F11 is equal to m1 into d square x1 by d square plus b1 into dx1 by dt plus b12 into d by dt of x1 minus x2 plus k1 into x1 minus x2 is equal to F of t. So this is the first differential equation. Okay, first differential equation governing the first node M1. Okay, and next we are going for the second node M2. Okay, so by observing this figure, the M2, there is no applied force here, and the opposing forces are due to this K1, B12, K2, B2, and M2. So 5 opposing forces are there. Okay, so it is drawn here, Fm2, Fb2, Fb12, Fk1, and Fk2. Okay, and in that this K1 and B12 is common for these two nodes. Okay, all other three, okay, K2, B2, M2 are independent of this, that is depend only on this node M2. Okay, K1 and B12 is common. So the equations will be Fm2 is equal to m2 into d square x2 by dt square, because x2 is the displacement here, and Fb2 is equal to b2 into dx2 by dt. It is only related to the mass m2, and we know that Fb12 is common for mass m1 and m2. So the equation is b12 into d by dt of x2 minus x1. Fk1 is equal to k1 into x2 minus x1. Fk2 is equal to only for the mass element m2. Fk2 is equal to k2 x2. Okay, and we are writing the force balance equation like that. Now there is no applied force, so all the opposing force is equal to 0 here, and we are substituting the values, okay, fm2 fp2 like that, and we are getting the second differential equation. Okay, so we have completed the first part of our question, that is the we have found the differential equations governing the system. Okay, and for converting it into the force voltage or force current analogy, just we have to make a change here, that is in the differential equation, mainly the two differential equations are depending upon the displacements. Okay, in all the terms there is a term displacement. Okay, so but here if you are converting it into that is the force voltage or force current analogy, based on the force voltage or force current analogy, the mechanical input is force and the mechanical output we are treating it as the velocity. Okay, so we have to represent all the terms in terms of velocity. Okay, so the first equation is m1 into d square x1 by dt square. Okay, so here we can represent this term using this velocity like that, that is m1 into dv1 by dt. Okay, instead of d square x1 by dt square, we have to substitute dv1 by dt. Okay, so m1 into dv1 by dt plus b1 into dx1 by dt. So this dx1 by dt is the v1, so b1 into v1, b1 into v1. Okay, so here b12 into d by dt of x1 minus x2. Okay, so b12 into v1 minus v2. We know that dx1 by dt is v1, dx2 by dt is v2, so b12 into v1 minus v2, v12 into v1 minus v2 plus k1 into x1 minus x2. Here only x1 is there, so for representing this x1 in terms of v1, we have to write it as k1 into integral of v1 minus v2. Okay, that is integral of v means it gives the displacement x. Okay, so here k1 into integral of v1 minus v2 dt is equal to f of t. Okay, and the second equation is also writing in terms of velocity as m2 into dv2 by d2 plus b2 v2 plus k2 into integral v2 dt plus b12 into v2 minus v1 plus k1 into integral v2 minus v1 dt is equal to 0. So this is the third and fourth equation. Okay, and next we are going to find the force voltage analog circuit. Okay, so by observing this figure, first we have to write the analogous elements for each one of the mechanical elements. Okay, so first one is f of t. So we know that for force voltage analog circuit, the corresponding analogous term is E of t. Okay, and for m1 it is L1, and for m2 it is L2, and for b1 it is r1. We know that b2 it is r2, b12 it is r12. So for representing k1 it is 1 by c1, k2 it is 1 by c2. Okay, so for writing this, we have to thoroughly study the force voltage analogous elements. Okay, what is the corresponding element in electrical circuit corresponding to the mechanical system? Okay, that we must know. Okay, and based on that we have to draw the electrical system. Okay, so here we know that there are two nodes, which means in electrical circuit there will be two mesh, that is two closed loop will be there. Okay, and for the first node we are applying an f of t, which means in the first loop we are having a voltage source of E of t. Okay, in the first loop we are having a voltage source E of t, and b1 is there. Okay, so instead of b1 we have to substitute, we have to draw a resistive element r1. Okay, so r1 is only common for the first loop. Okay, and instead of m1 we have to draw an inductor L1, and this k1 and b12 is common for these two nodes. So the k1, the corresponding element is corresponding to k1 is 1 by c1, that is a capacitor, and b12 it is a resistor. So capacitor c1 and resistor r12 is common for two loops, two closed loops. Okay, so we are drawing it like that, that is the first loop. Okay, this is the first loop, this is the first loop. Okay, so E of t, apply instead of f of t we are drawing E of t, and instead of m1 we are drawing L1, and instead of this b1 we are drawing r1. Okay, and we know that this k1 and b12 is common. Okay, instead of k1 we have to draw capacitor c1. So capacitor c1, this is a capacitor c1 is drawn like that, in such a way that it is common for the two loops, two closed loops, and instead of B12 we are having R12. It is also common for the two loops. Okay, so this is the first figure. And for the node 2, okay, we know that here K1 B12 K2 B2 M2 is there. So instead of M2 we have to draw L2, and K2 means 1 by C2, there is a capacitor C2. B2 means we have to substitute a resistor R2, and this K1 and B12 is common. We are already drawn that values, that is capacitor C1 and R12 is already drawn here. Okay, so we have to draw the second loop. So L2, instead of this M2 we are drawing an L2, and instead of this B2 we are drawing an R2 here. Okay, and instead of this K2 we are drawing as capacitor C2 here. Okay, so this is the second loop. Okay, and instead of this velocity, okay, velocity element, we are having the current in the current is the analogous value in the electrical circuit. So current is flowing here, I1 I2. So this is the corresponding force voltage electrical analogous circuit. Okay, so this gives the better explanation of each of the two loops. Okay, so by using the Kirchhoff's voltage law we can write the loop equations. So that is E of t is equal to first equation L1 into di1 by dt plus R1 into I1 plus R12 into I1 minus I2. Okay, here I1 is the current flowing here, I2 is the current here, so R12 into I1 minus I2 plus current flowing through this capacitor is 1 by C1 into integral I1 minus I2 dt. Okay, so first equation, first loop equation. Second loop equation is, so starting from here, L2 into di2 by dt plus R2 into I2 plus 1 by C2 into integral I2 dt. Then coming over here, R12 into I2 minus I1 plus 1 by C1 into integral of I2 minus I1 dt is equal to 0. There is no applied voltage here, so it is equal to 0. Okay, so this is the corresponding loop equations. So we can compare this value, this equation, with our two differential equations. So this is the first differential equation. So instead of M1 we are substituting L1, and instead of this d square x1 by dt square we are having this that is this di1 by dt, that is instead of this M1 dv1 by dt. Okay, 3 and 4 we can compare these two equations with the electrical equations we have obtained. M1 into dv1 by dt means L1 into di1 by dt. Okay, you can see here L1 into di1 by dt, and b1 into v1 means R1 into I1 and I1. Likewise we can compare all these values. Okay, so it is observed that the mesh basis equations 5 and 6 are similar to the differential equation 3 and 4 governing the mechanical system. Okay, so this is the force voltage explanation, and next we are moving to the force current analogous circuit. And we know that in the case of force current analogous circuit, for a mechanical system input is f of t and output is velocity, but in the case of electrical system input is current source and output is the voltage. Okay, so instead of this f of t we have to substitute I of t current source, and M1 instead of M1 we have to substitute a capacitor C1, M2 C2, and B1 is 1 by R1, B2 1 by R2, B12 1 by R12, and K1 1 by L1, K2 1 by L2. Okay, so these are the corresponding analogous elements in electrical circuit. And we know that there are two nodes in mechanical system, so when we are drawing the force current analogous circuit there also be two nodes. Okay, two nodes, and we are considering the first node. So in the first node we are applying a force f of t. So in the first node there will be a current source I of t should be there. Okay, and instead of this b1 there should be a resistor r1. Okay, r1 should be connected to the node 1, and m1 is there, so we have to connect a capacitor C1 to the node 1, and K1 and B12 is common for this two node. Okay, so K1, instead of this K1 we are having a inductor L1 here, 1 by L1. Okay, inductor L1 here, so L1 should be drawn in such a way that it is common to the two nodes. Okay, common to the two nodes 1 and 2. Okay, and B12 is also common to the two nodes. Okay, so the figure is like that. The first node is this and the second node is here. Okay, this is the first node and this is the second node. So for the first node we are having an I of t is there and a capacitor C1, okay, is there, and resistor R1 is there, and a common resistor R12 is there, and a common inductor L1 is there. Okay, that is here the K1, okay, K1 and B12 is common. Okay, so this inductor L1 and R12 is common to the two nodes. So L1 and R12 is common to the two nodes. Okay, so likewise in the second node also we are having K1, K2, B12, B2 and M2. Okay, so instead of M2 we have to connect a capacitor C2 to the node 2, and K1 and B12 is common for the two nodes. It is already drawn here. Okay, and K2 is we have to connect inductor L2 to the node 2, and B2 is a resistor. We have to connect a resistor L2, resistor R2 to the node 2. So this is the second node. Okay, C2 is connected to the second node, and R2 is connected to the second node, and L2 is connected to the second node. R12 and L1 is the common. So this is the corresponding force current in electrical analog circuit, and from that we can write the node equations. Okay, so node equation is I of t is equal to we know that C1 into dV1 by dt. Okay, current flowing through this capacitor is C1 into dV1 by dt. Current flowing through this resistor is V1 by R1, 1 by R1 into V1, and current flowing through this resistor is 1 by R12 into V1 minus V2, and this inductor is 1 by L1 into V1 minus V2 dt is equal to I of t. This is the first node equation. Likewise we can write the second node equation like that: C2 into dV2 by dt plus 1 by R2 V2 plus 1 by L2 into integral V2 dt 1 plus 1 by R12 into V2 minus V1 plus 1 by L1 into integral V2 minus V1 dt is equal to 0. Okay, so it is also observed that the node basic equations 7 and 8 are similar to the differential equations 3 and 4 governing the mechanical system. Okay, so I hope it's clear. So with that we are concluding the force current analog circuit. Okay, so thank you.